Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial, guys, we are still solving quadratic equations, right? And in this question, right, we are basically given a quadratic equation, right, that has two unknowns. We've got a p, we've got an x here, right? So we basically need to express the roots of the quadratic equation 2x squared minus px plus 1, which is equal to 0, in terms of p, and hence show that the roots are irrational if p is equal to 4. Okay, so the whole point of basically me doing this lesson with you guys today is to introduce you guys to the term roots, right? So that when we actually do nature of roots, you guys actually have an idea of what a root is. What are we actually talking about when we are talking about a root? Okay, because this question is asking you to actually express the solution of this equation, right, in terms of p. Express the roots of this equation in terms of p, right? So we are basically asked to solve for x and express our answer, right, in terms of p. Okay, so what are roots? Okay, what are we talking about when we are talking about the roots of a function, the roots of a particular equation, right? So let's look at this particular quadratic function, right, because we are working with a quadratic equation, right? So let's say you were given this function, this parabola, okay, and they said to you that, okay, this x-intercept here is -2, and this x-intercept here is 2, all right? So what are the roots of this function, right? The roots of this function is x is equal to -2, x is equal to 2. So when we're talking about roots, we are basically talking about where is the function equal to 0, okay? If we were to substitute this -2 into the equation of this parabola, right, we would actually get 0. So when we're talking about roots, they're basically asking you, what are the values of x? Where is this function where is this function intersecting or cutting? What is the x coordinate where this function is cutting our x-axis? Okay, so when we're talking about roots, guys, right, in this case, right, what are the roots of this equation? They basically want you to determine what is x, what is the solution of this equation, right? If you're looking at a function, what are the roots of this particular quadratic function? Okay, in this case, we can see that, okay, the roots are the x coordinates where your function cuts what? The x-axis. So it's x is equal to -2 and x is equal to 2. Okay, so it's very important that you guys understand that concept, because we're going to be speaking about it a lot when we look at problems where we're talking about the nature of the roots. Okay, so please remember that, please take note of that, okay, because we're going to also use that in the next video tutorial where we're talking about nature of roots. Okay, so before we get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a new video tutorial, guys. And also please don't forget to give this video tutorial a huge thumbs up, because it really helps the channel grow and it helps the channel to reach more learners that want to better their mathematics marks. So without any further ado, guys, let's get started with today's video tutorial. So like I mentioned, right, in this equation, in this lesson, we're going to be looking at this question, and this question wants us to express the roots of the equation 2x squared minus px plus 1, which is equal to 0, in terms of p. So already here, guys, we know that we want to determine what is the solution to this equation, to this quadratic equation in terms of p. We want to solve for x, right? And whatever answer that we're going to get, it will be in terms of p. Okay, so here, right, I'm going to just look at part A of this question, and we're going to look at part B after we basically found the solution to this equation. Okay, so let's basically look at this. We are given the equation, the quadratic equation, 2x squared minus px plus 1, which is equal to 0. Okay, so here we can see that we are given a quadratic equation that is in the form of ax squared plus bx plus c is equal to 0. Okay, here, guys, we cannot use our normal factorizing techniques. Why? Because we've got another unknown. We've got an unknown here of p, right? So it's basically going to be impossible for us to factorize this equation by obviously using the two brackets, finding the factors of 1, that if you multiply them, they give you 1, and if you add or subtract them, they'll give you p. Okay, so in this case, right, we know that we'll have to then use the quadratic formula to help us solve for x. Okay, so what does the quadratic formula say? It's x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, right? Here, all that we need to do is we're going to substitute the b, we're going to substitute the a, we're going to substitute the c. Okay, so what is our a? Our a is the coefficient of our x squared, that is our a. What is our b? Our coefficient for our x, that is our b. What is our c? Our constant is our c. All right, so let's substitute those values into this formula. So it's minus, what is our b? Okay, so it's minus, what is our b? It's minus p plus or minus, what is our b? It's minus p all squared minus 4, what is our a? It's 2, what is our c? It's 1 all over 2, what is our a? 2. All right, you can simplify this further. So to simplify this further, minus times a minus is a positive p. So we're going to have a positive p plus or minus negative p all squared. That is going to just give us a positive p squared, right? Negative 4 times 2 is a negative 8 all over 2 times 2 is 4. So now, do you see that we've now expressed the roots? We've found the solution, right? We found the solution of this equation, 2x squared minus px plus 1, which is equal to 0, in terms of p, because we actually found that, okay, the solution is when we solve for x, right? It's going to be x is equal to p plus the square root of p squared minus 8 all over 4, or x is equal to p minus the square root of p squared minus 8 all over 4. Okay, so we can't simplify that any further. Okay, that is basically us expressing the value of x, or the value of our roots, okay, in terms of p, right? And then let's look at part b of this question. It's saying, and hence show that the roots are irrational. Okay, what is an irrational number? Okay, if p is equal to 4. Okay, so now the first thing that now we can basically see that here, right, with this part b, we need to know what is an irrational number, right? But before getting to that, right, it's basically telling us that, okay, we need to show now that these roots, okay, are actually irrational numbers. If you substitute in place of a p, you put a 4. Okay, so let's do that. Let's substitute p is equal to 4 for the roots that we've just obtained. Remember, we found that x is equal to p plus square root of p squared minus 8 all over 4, or we said that x is equal to p minus square root of p squared minus 8 all over 4. Okay, so if your p is equal to 4, what do we need to do? Therefore, that means that your x is going to be equal to, when you see a p, you're going to put a 4, 4 plus 4 all squared minus 8 all over 4, or x is equal to, where you see a p, you'll put a 4 minus square root of 4 all squared minus 8 all over 4. Right? So if you simplify this further, right? So it's going to just be 4 plus 4 squared is 16, right? Minus 8 is 8. So it's going to be 4 plus the square root of 8 all over 4. Okay, or x is equal to, still it's 4. 4 squared minus 8 is going to be, so 4 squared is 16 minus 8 is still 8 all over. Okay, if you simplify this further, it's going to be 4 plus the square root of 8 is 2 square root 2 all over 4. Okay, so here we see that we've got a common factor of 2. So if you take out a 2, you'll be left with 2 plus square root 2 all over 2 and 2, right? I took out a 2 in the numerator, and in the denominator, the 2 and the 2 cancel, right? Therefore, our x is equal to 2 plus square root 2 over 2, right? That's your final answer. We're going to do the same thing here. X is equal to, right? That is a 4 minus the square root of 8 is 2 square root 2 over 4, right? If you basically take out a common factor of 2, right? Because 2 is common at the top, right? And at the bottom, so it's 2. You'll be left with a 2 minus square root 2 over 2 times 2. 2 divided by 2 is 1. Final answer is 2 minus square root 2 all over 2, right? If you basically write this answer as a decimal, right, guys, you can literally, from here, you can even just put this in your calculator, but I choose to basically show you guys how your calculator gets your answers, okay? But from here, you can even just go straight to what the answer is, okay? So if me doing the whole calculations bores you, right, just know that you can also just put it into your calculator and get your final answer. All right, okay, so x is equal to 2 plus square root 2 over 2, or x is equal to 2, or x is equal to 2 minus square root 2 over 2. Okay, so those are basically the roots, the solution for this equation. Okay, that is basically where our function cuts the x-axis. That is where our function is equal to 0. Okay, and then from here, right, the question basically goes on to ask us, right, show that now these roots are irrational. Okay, guys, what is an irrational number? An irrational number is the number that cannot be written as a simple fraction. Okay, so numbers that actually can't be written as simple fractions are the square roots of your prime numbers. So the square root of a 3, okay, that cannot be written as a simple fraction. Square root of 5, it cannot be written as a simple fraction. Square root of 7, right? If you were to convert these values from surd form into decimal form, you'll find that there's no pattern, okay? Right? If you were to basically convert the square root 3 into a decimal, you'll actually get that your answer is 1.732050808. Okay, do we see that? Okay, there's no pattern here, right, that is going on. It's not 7373737. Okay, so that tells us that, okay, this value, that is why the square root of 3 is actually an irrational number. Same with the square root of 5. If you put the square root of 5 into your calculator, you'll get an answer of 2.23606, right? You'll see that there's no pattern here as well. So that is why I'm saying the square root of 5 is an irrational number. Square root of 7 as well. There won't be a pattern. So that is why I'm basically saying that these numbers are irrational numbers. So numbers that are irrational numbers are numbers that cannot be written as your simple fraction, right? You cannot write it as 1 over 2, 3 over 5, right? There is no pattern when you were to basically convert that number in from surd form or from a fraction into decimal form. There's no pattern. So what are we noticing with these roots that we've basically obtained here, right? Convert this number from surd form into decimal form. What do you actually get? You'll get that, okay, for this one, right, where it's 2 plus the square root of 2 over 2, if you were to press the SD button on your calculator, you'll find that you get 1.70710678. What are we noticing? There's no pattern. No number is repeating. No number is like recurring, right? There's no pattern. Therefore, we see that, okay, this root is an irrational number. Okay, let's have a look at the other root. When you press the SD button, you'll find that x is equal to 0.29289321888. Okay, so we see that as well, right? No number is repeating. There's no pattern. It's not 292929. Okay, right? There's no pattern. It's not 29999, right? It's not recurring. So therefore, we see that also this root is an irrational number. Okay, so then we've basically shown that we've expressed the root of this equation in terms of p, right? Because we were able to then show that, okay, x is equal to p plus. We've expressed the solution in terms of p, and hence we've shown that the roots are irrational. Okay, when you basically substitute a value of p that is equal to 4 into these roots, we found that these roots are actually irrational because there's actually no pattern here, right? No number is recurring. So then we can, and this value cannot be written. We can see that we got a 2 plus square root 2 over 2. This is not a simple fraction that we use that we normally work with, right? So this value is not a simple fraction. This number cannot be expressed as a simple fraction. Okay, therefore we can see that, okay, we can conclude that the roots are irrational, okay, in nature. Okay, so that is basically how you go about solving this type of a question, right? And like I mentioned, I'm just going to repeat. I just wanted you guys to understand what it is that I'm basically talking about when we are talking about roots. Okay, we are talking about where is this function cutting our x-axis, right? Where is the value of y 0, or where you substitute these roots, right? Where is the value, where is the function equal to 0? So that is basically what we are talking about when we're talking about what is the solution to this equation. Okay, and I also explained to you guys what I mean by roots by using a diagram that, okay, that is where your function cuts your x-axis. All right, so that is it, guys, for today's video tutorial. I hope you guys enjoyed this video tutorial. In the next video tutorial, guys, we're gonna go deep into the nature of roots. Okay, and it's very important that you guys watch that video tutorial because it's also going to help you guys a lot when we get to working with our quadratic functions, right? If you already know what the b squared minus 4ac is, right, then that will help you basically even just determine what the roots are going to be. Okay, so please make sure that you watch that video tutorial, guys, the next video tutorial that I upload, and I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.